Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 721, accounts merge. Given a list of accounts where each element accounts I is a list of strings, where the first element accounts I0 is a name, and the rest of the elements in the list are emails representing emails of the account. Now we would like to merge these accounts. Two accounts definitely belong to the same person if there is some common email to both accounts. Note that even if two accounts have the same name, they may belong to different people, as people could have the same name. A person can have any number of accounts initially, but all of their accounts definitely have the same name. After merging the accounts, return the accounts in the following format. The first element of each account is a name, and the rest of elements are emails in sorted order. The accounts themselves can be returned in any order. So in that example 1, accounts is a list of email accounts. So the first element of this account is a list, and then this list contains the username, which is John, as the first element, and then the rest of element in this account list is the emails associated with this user. In this example, the first and second joins are the same person as they have the common email address johnsmith@mail.com. So in this case, these two can be merged. So the original list, those two lists can be merged into one list because they belong to the same user. The third John and Mary are different people as none of their email addresses are used by other accounts. We could return this list in any order. For example, the answer in this output is one of the options. The other option is, like say, another option is we can return, like say, the list of Mary first, and then this third John, and then the merged John. So that would still be acceptable answer. In the example 2, so no overlapping account or no common email address. So in that case, the accounts are not merged, and we just return the account list. So how to solve this problem? So when we are trying to merge accounts, it's like we are performing the union operation in the union find data structure. So here, so each element, so remember when we initialize the union find data structure, we input n that represent, okay, we find that that's kind of the n subset. So here each list in the original accounts input can be uh, one of the elements. So basically, we are just performing merge on the indexes for those lists. Let's say this list has index 0 in the original accounts. This list has index 1 in the original accounts. When we're trying to merge those two accounts together, we are actually merge 0 and 1. So in that case, let's code the solution. First, let's code the standard union find data structure. I have a separate video, a standalone alone video on the union find, and then in that video I explained the union find in details, basically how we went from the naive implementation of union find to the optimized implementation using path compression and union by rank. So here I'm just going to code the optimized version of the union find directly. If you want to check the details for the union find implementation, please feel free to check my other video on the union find. So I have a parent. So in that case is I. Initially, everyone's parent is just itself, and then we have a rank. Initially, everyone's rank is 1 because everyone has itself as the parent. And then we define the find function. So given x, we find its parent. So here, well, x is not equal to self.parent x. So in this case, which means we haven't defined its parent yet. So in this case, we use a path compression. So this is the path, our path compression. And then we assign its parent to itself. And then we just return x. And then we also define the union. Self x1, x2. We first using find operation to find their parents. And then after we find the parents, we compare if P1 equals P2, which means these two elements has already been merged before. So in that case, we just return false. Else, we compare the rank. This is union by rank, another optimization performed to optimize the union find implementation. Self.parent P1, P2 equals P1. Self.rank P1, self.rank P2. Else, self.parent P1 equals P2, self.rank P2, self.rank P1. So basically, this is union by rank. So basically, when we have P1 and P2, we need to determine, okay, if we are going to means like, okay, so P1 has a higher rank than P2. In that case, we assign P1 as P2's parent. Otherwise, we assign P2 as P1's parent. And then after that, we just return true. And then here, let me import, let me use ownership. Let's say for each email, we want to track its owner, because we need to identify if an email has occurred before. So in that case, we use a dictionary data structure to track, okay, if this email has occurred before, then what is the index of the group that email has occurred before. For example, when this johnsmith@mail.com occurred before, the corresponding index is 0. And then when this johnsmith@mail.com occurred right now, we check, okay, if this John Smith has occurred before, and then if it's occurred before, it can be found in this ownership, and then we know this owner, the corresponding owner is the group with index 0 in the original account's input. So basically for I, user emails in accounts, enumerate accounts if, and then for email in user emails 1, if email in ownership, which means this email has occurred before. So in that case, ownership, we perform union operation. So to union their owner group. So we need to initialize the union find. Okay, so if it occurred before, then we need to get the previous owner group. and then we union with the current owner group. So which means we perform the account merge. And then after that, we update the email equals I. So after that, we assign the unit. So basically, after we successfully perform the union operation to merge accounts, let's say if we find okay the same email, if two groups or two lists that has common emails, then we merge these two. So that's kind of how we perform the union operation. And then after that, we need to just return the results. Basically, returns the corresponding user and emails in the same group. Basically for I, user emails in enumerate accounts if result I actually result uf dot find I. So we find the corresponding parents dot update user emails. So basically here we use a set. So result is a default dictionary of set, so that we kind of remove the duplicates. Let's say as we are looking through this, let's say at the very beginning our set we add these emails to the set, and then now we have uh, we have another group of emails, and we know they belong to the same account. So in that case, we need to update the set to include those emails as well. So in this case, using set update, it can take care of the duplicated email, this johnsmith@mail.com. And in the end, we just return accounts I 0. That's how we retrieve the name. Okay. And then that plus the result. Plus emails for I emails in result.items. And then we also need to sorted the list of emails. So this is our solution. So let me go over the idea for solving it one more time. So basically, we need to merge account, and then our merge is performed on the account level. So this account contains a list of account. So each list represents one account, and then in this account list, the first element is the username, and then the rest of the elements are the emails associated with this user. So what we need to do is to find any two account lists belong to the same user. For example, these two account lists, they have both John, and then they have a common email. That's the common email is a criteria to determine if we can merge the two accounts or not. So here, both accounts contain the common email johnsmith@mail.com. So we merge these two accounts into one, and then they represent the same account. So, and then for this account, so Mary, we did not have any common or overlapping email, so it remains as Mary. This John has the same name, but since it has different set of uh, emails, so in that case, it's also a different account. So by performing the account, so for performing the account merge, we use the union find data structure. So that's why first we code a standard, pretty standard union find implementation. In this implementation, I used the path compression and then also union by rank to optimize it. And then when I write the solution for this one, I need to first identify the account each email belong to. So the account is represented by the index in this accounts. So the first account is johnsmithmail.com, johnnewyorkmail.com. This account is represented by its corresponding index, which is 0 here. And then this account is currently represented by index 1. This account represented by index 2. This account represented by index 3. So that's the initial index for those accounts. Then we need to perform union find on the account level. So basically on the index from 0 to the number of accounts minus 1. And then how we are going to perform the union find? We first need to identify if we want to perform the union operation. So we use ownership dictionary to keep track of the account each email belongs to. So in that case, after we iterate through every email, we check if this email has already belonged to some other account, which means if this email has already occurred, being added to this ownership dictionary. If it is, we fetch the corresponding account. So that's the account this email occurred. And then this I is the current account. So basically this email occurred in 2 accounts that's represented by different indexes. What we need to do is to merge these 2 accounts. So we are doing that by perform the union operation in union find. And then after doing that, we update, this we assign, let's say, to track this email has appeared in this account I. This is happening regardless of whether or not we perform the union operation. Basically, for every email, we just keep track of the account this email belongs to. And then after that, we successfully perform the account merge. Now what we need to do is just to return the results. So basically for every for I and user emails in this input enumerate accounts, we need to find the parents for this I. So because this I is the original account, and then we need to find the parent. That's kind of like the merge account. So we find this parent and then we add the corresponding emails to this to the set of its parent. In that case, we merge all the accounts together. That for the accounts that belongs to the same account. And then when we return the result, this is the username. Let's say in this case it's our John. And then for the emails, we need to sort it because the problem returns like the rest of the elements are emails in sorted order. So that's our solution using union find.